Hi, I'm Dr. Incognito. In this video, we'll find the average value of a function, and we'll also determine where the function takes on its average value. So in general, the formula for the average value of a function over an interval is 1 over b minus a times the integral from a to b of f of x dx. So this will give us the average value of the function y equals f of x over the interval from a to b. So in our example, let's find the average value of f of x equals x cubed over the interval from 0 to 3. So the formula says that the average value will equal 1 over 3 minus 0 times the integral from 0 to 3 of x cubed dx. So this is equal to 1/3 times the integral from 0 to 3 of x cubed dx, which is 1/3 times, here we have x to the 4th over 4, from 0 to 3. And this works out to be 1/3 times 3 to the 4th is 81. So 81 quarters. We plug in 0, we get 0. So 81 over 12 is the average value of the function. If we were to, let's investigate this a little bit. If we were to draw the curve y equals x cubed over the interval from 0 to 3, the y value here is 27. And the curve looks roughly like this. If we were to draw a line between 0, 0 and 327, the average height of the line would be exactly the average between 0 and 27, which is 13.5. 27 halves, 13.5. And we can see that our curve y equals x cubed is below the line, so the average should be less than this. And our average is 81 over 12, which is substantially less than that. 87 over 12 is a little less than 7. 84, 12, in fact, it looks like it's 6 3/4. 7 would be 84 twelfths. So our average value is indeed less than 27 over 2. Then one other thing we could do in this situation is we could ask, where does our function take on its average value? Our function f of x equals x cubed is continuous over the interval from 0 to 3. And so a theorem called the mean value theorem for integrals says that our function will actually equal its average value somewhere in the interval from 0 to 3. So in other words, the lowest height of the function on the interval is 0, the highest is 27, 81 over 12 is somewhere in between, and therefore there should be an x between 0 and 3 such that f of x is equal to 81 over 12. This also sounds like the intermediate value theorem. So let's see if we can solve the equation f of c equals f av for c. So f of c would be c cubed, and that would be f av is 81 over 12. And so c would be the cube root of 81 over 12. That could be simplified a little bit, since 27 is a perfect cube that divides into 81. This is the cube root of 27 times the cube root of 3 over the cube root of 12. The cube root of 12 we're not going to be able to do anything with. So this is 3 times So the cube root of 3 over the cube root of 12 is the cube root of 1/4. So this is basically 3 over the cube root of 4. 3 over the cube root of 4. That's our C value, and that is between 0 and 3. It's clearly positive, and since the cube root of 3 over 4 is greater than 1, the cube root of 4 is greater than 1, 3 divided by that is less than 3. So there's our C value. So somewhere in here is the number 3 over the cube root of 4, and at that value, the height of the function is 81 over 12. So this is how we compute the average value of a function, and then after we have done so, we can try also to figure out where the function actually attains its average. It should happen in at least one point over the interval if the function that's given is continuous on the interval. So in our case, it happened at this unusual looking number. Okay, thank you for watching this video. I hope you found it helpful.